All right, hey, this is Horner, and we're going to look at the force, charge, and change in position. And this is for the lab that you're doing. These are the background notes. If you don't do these, you're going to have trouble. And so you'll just want to make sure you do them. We're going to find out using this virtual website, well, I guess it's a virtual lab on a website, how force and charge are related and how force and change in position between two charges are related. So to do that, we've got two charges. This is the same thing that you'll see in the actual lab itself, and we need to draw a free body diagram for these two. So don't freak out, it's not really hard. In fact, you'll already see kind of they've done that here, but we're only going to do it for just one because we just need it for just one of them, and then that way it's a little bit easier to go in and find out some of the math that we need to do for it. So let's go ahead and do this charge. Actually, let's do charge B. So we're going to put a dot for the charge. This is our string. I'm going to get rid of that box thing there. All right, here we go. We'll put the box thing up here maybe. And there we go. So there's our, so now we've got this. And we need to go ahead and put in all of the components for this. So we know that we have straight down, this is mg, so that's a force. We know that up and to the left we have tension, and so that's T. And then we have a force of A on B, so that is the force due to electricity. So that is Fe. And so now at this point we need to go ahead and make our axes. So let's say that up is positive y and to the right, sorry, is positive x. That's not real straight, but it'll do. And we need to go ahead and break up this tension force into two components. So let's go ahead and put this down here, and then we're going to kind of go straight across as best we can. And we want to know what is the angle that is right here. So we want to know what is the angle that we have. So we're only really going to, well, let's just go through and do it. We have the force of electricity, and that is what we are trying to find. We're going to try to make an equation for the force of electricity. And we've got to base it on this angle that we have. So notice that that is the angle that is right here, and that's the angle that you're using in your lab. So you've got to make sure that you do this correctly and use this diagram. This side of the triangle, remember, is going to be our cosine side. So this is T times the cosine of the angle that we have here. And then the opposite side is T times the sine of the angle. So now you've got both. And we're going to calculate the force. So let's go ahead and use everything that we have to go through and calculate the force. Let's first do the sum of the forces in the x direction. Now this thing is static, which means it's not moving. There's no acceleration, so we're going to say that's equal to 0. And we're going to do the sum of the forces in the y, and that's also equal to 0. So in electrostatics, this is going to be one of the only times that we're going to use forces. But it's a good review of some of the things that we've done in the past. So the sum of the forces in the x direction are, we know we have the electric force, so that is Fe, minus, and then we have T sine of the angle, and that is equal to 0. So this one's really easy. The force of electricity in the x direction is equal to T times the sine of the angle. Let's do the same thing in the y direction, so that's up and down. We'll make T times the cosine of the angle, and that minus mg is equal to 0. And so now we can say that T times the sine of the, oops, sorry, not T times the sine, we want T times the cosine, so we'll back that off, that's my fault. T times the cosine of the angle is equal to mg. All right, we want to combine these two equations. Well, the only way to do it is to get something common on both sides. So the only thing that we have in common is T. So let's solve each one for T. So this one is T is equal to the force of electricity divided by the sine of the angle. And this one is T is equal to mg over the cosine of the angle. So now let's just set these two things equal to each other, or you could say we're going to plug in the mg cosine of the angle and put it in on this side, or we can take this and plug it in on this side. Either way you do it's fine. So I'm going to take Fe, which is the, not iron, but it is the force of electricity, and then that is sine of the angle, and that is equal to mg over cosine of the angle. So let's go ahead and solve for the force of electricity. Force of electricity is equal to mg times the sine of the angle, and we're going to divide that by cosine of the angle. And yes, you are correct, sine over cosine is tangent, so the force of electricity is equal to mg times the tangent of the angle. Why is this important? Well, it's important because this is how you calculate the force of electricity in your lab. Let's go ahead and go back to the spreadsheet for the lab, and you'll notice that in the spreadsheet for the lab it says that you need to have the force of electricity both on both of the on both of these tabs. So this one is also force, and it is the force of electricity. So to do that, remember that you're going to right here put in mg. So this will be the mass times gravity of our particle, and then we're going to take that times the tangent of the angle. So whatever your angle is. You'll need to do this in your calculator. Don't set up an equation to do it, because if you set up an equation, it does it in radians, and you don't want it in radians. You actually want this in degrees. So do this one by hand. Please don't do it using the spreadsheet unless you really know what you're doing. And I think that should help you out tremendously in the lab. And that is it.